Next thing we're going to look at is indication. Remember, one of the key terms was that we don't have false indications, but we also need to make sure that we indicate quickly when there is an actual problem. And we have to indicate where that problem is, where that fire, overheat, smoke is. And then we have to provide an indication when that threat's been dealt with, when the fire's been put out, or when the smoke has been, or whatever's causing the smoke has been extinguished. So that's done through typically multiple methods. Almost, they're going to have some kind of a light and an oral warning system at the very minimum. An oral warning system could be a fire bell, or most of your new aircraft that have electronic or computerized voice systems in them will tell you, left engine fire or APU fire. It'll actually tell you what it is, along with a bell or warning horn. Various ICAS and ECAM messages. This is all, most of the time goes through, it's a combination of your fire and overheat indicating and your central warning system kind of working together to provide these. And then the actual items you use to fight, say, a fire, the pull handles, push switches, toggle switches, they are going to often have a light in them to draw your attention to it. So if you have a fire in your left engine, the fire handle or the fire button for that engine will light up as well, so it's easy to find. But we don't want to accidentally fight a fire when there isn't one. So they're often guarded or they dual action. Okay. What I mean by that is like a fire handle. But we're not quite there yet. Fire handle, you have to pull and then turn, not just push or pull. But our extinguishing agents, most common today we have are halogenated hydrocarbons, also known as halon, and they're there to displace oxygen. Their advantages are they don't have any residue, and they don't conduct electricity in case of an electrical fire. They also have low toxicity. Low toxicity does not mean they can't hurt you. Okay? Oxygen displacing that can starve a fire can also suffocate you. Remember, suffocation and toxicity are two different things. Okay? So you don't want to be in, say, a cargo hold when one of these things goes off. It's probably not going to cause long-term health effects, but it has the chance to kill you right then and there if it gets rid of all the oxygen that's around. Okay? So low toxicity, but has the ability to hurt you because of the oxygen displacement. The other issue with halon, anyone know what the big issue is worldwide? They're an ozone depleting chemical, the various halons. And so actually a lot of these, they've stopped production of them. So most of the halon we use today is recycled, recovered and recycled when possible. Huh? How do you recover it? I have an old fire bottle. I don't just empty it into the air. They send it in, they suck it out and put it into the new fire bottle. Yeah. If you pop off a fire bottle and it goes, that's gone. It goes up and eats away the ozone layer. There's nothing you can do to get it back that way. But the big issue with halon is that it has this nasty habit of reacting with burning metals, like lithium-ion batteries. This is the reason when you get on a flight, they say you cannot have rechargeable batteries in your checked luggage. Not only are they out of sight in an area where no one would necessarily know that there's a fire, but the firefighting tool we have in the cargo compartment actually reacts with those and makes it worse. That is why they're so critical about it. It's not just that it's hard to put that fire out, it's that the tool we have to put it out makes it worse. Okay. Other inert gas, CO2 is a common one for oxygen displacing. It also is no residue. It has a cooling effect. Both of these have a cooling because their pressure drops significantly when they go off. The problem with CO2 though is it's not temperature stable. That means that your bottles that contain it, the pressure can vary widely depending on how hot they are. And they can easily, if they get overheated, they can easily get overpressurized as well. So halon is much more stable at different pressures. Most aircraft carry a water fire extinguisher. This is more of a portable thing in the cabin. It's non-toxic, it's cooling, it's fairly easy to clean up, but it does leave a bunch of water behind. And it has limited application. This is pretty much good for things like paper fires. And then the fourth one we have here, dry powder. Dry powder is in a lot of fire extinguishers. The fire extinguishers in this building probably all contain dry powder. It's a great, it snuffs out fires and that kind of thing, monoammonium phosphate. It separates the fuel. It creates a barrier between the fuel and the oxygen. Okay? But it leaves residue everywhere. I'm sure you've all seen the white powder that gets left behind by a fire extinguisher. The problem with that in aviation is that white powder that's left behind is corrosive. In fact, highly corrosive to aluminum and other aviation metals. So, plus you don't want to be breathing it and that kind of thing in like a cabin. So you don't see them as much. Some portable extinguishers in the cabin may contain this. The biggest spot you may see it is for ground firefighting, but most ground firefighting today, they use more foams than powders. They use foam-based suppressants, water and foam. What's that? Foams are also corrosive. I think they contain a similar chemical, just a foam. And they're cancerous and they contaminate water supplies. I don't know if you're aware, Battle Creek here, this area, all the groundwater around here is contaminated with PFAS, which is from the firefighting practicing activities they used to do over at the guard base here. So, so there's a couple. We have both portable and fixed fire extinguishing equipment. In the cabin is where the portable stuff is. So cockpit crew and cabin crew can use these. And you'll have different versions. You'll have halon, CO2, occasionally dry powder, and typically water. And they're classes. You've probably seen these on other fire extinguishers around. But Class A is your ordinary combustibles, things like wood, paper, etc. And water works really well on Class A. Dry powder works well on Class A. Halon, CO2, not so much, because most of the time these are in areas where they're not in an enclosed space. Right? Halon, CO2, they work by displacing oxygen. The problem is if the space isn't enclosed, the halon and CO2 go away and the oxygen comes right back again. So the dry powder that creates a barrier between the air and the burning chemical or the burning item, or the water that cools it to the point that it snuffs it out. Flammable liquids like grease and oil. You can use things like dry powder or CO2 and halon if you have more of an enclosed area. Okay, but you don't want to put water on that. You've all heard the horror stories about putting water on a fry pan fire and burning down your house. C is electrical fires. Again, for electrical fires, you don't really want it. Dry powder and water really aren't the greatest. Now you're getting into the halon CO2 category. You're just going to try to snuff it out with that. And then finally, D is your flammable metals, typically dry powders are what are used with those. Because again, halon actually has the opposite effect with flammable metals. It can feed the fire. It can increase the intensity of the fire. Flammable metals are incredibly hard to put out. We had a dust collector filter catch fire at the factory. Basically a filter that was full of dust, metal dust. The fire department showed up, took one look at it and said, yeah, you're just going to let that burn until it's done. It's in a dumpster full of steel. It's not going to hurt anything. We'll sit here and monitor it, make sure it doesn't burn anything else down. But they didn't even, South Bend Fire wouldn't even try to fight it. It burned for like 6 hours too. It burned for a long time. So the other one then is our installed extinguishers. So permanently installed. They're going to be in protected locations so that they're not prone to damage. But they're going to protect areas like your turbine engine compartments, that fire zone. Same thing with the APU, as well as cargo and baggage compartments and lavatories. The containers themselves are going to hold your pressure holds agents as a liquid. Okay, gas, halon becomes a gas, carbon dioxide becomes a gas, but they're liquid when they're inside of these. If you pick one up and kind of move it, you can feel the liquid sloshing around inside. And then nitrogen as an inert gas is used to increase that pressure and keep it pressurized. We don't want them to explode if they get too hot, so they have temperature and pressure relief systems on them. And most of them are constructed of stainless steel or titanium. Aluminum doesn't have the tensile strength needed to contain these. So there you can see those are a couple of engine bottles right there. They're sealed with what's called a frangible disc at the outlet. You can see it's got score marks in it, which means it can be broken easily, somewhat easily. And so to pop this open, there's an explosive squib right here. This little end on the right is a little projectile type thing. When this has a charge applied to it, a little bit of explosive powder ignites, and it sends this slug at the end into that disc to pop it apart, to break it open. And that allows the bottle to discharge. It's all contained inside of a thing. It's not going to be shooting. It's not like we're shooting a slug through the airplane or anything. It's all contained inside of like steel connectors. Okay. There is a strainer inside. This is where it's going to, halon's going to come out. It's going to go through the strainer and then out here to, say, an engine or the APU. The strainer is to keep the metal bits of this from going out and clogging the pipes further downstream. Okay. And that's all known as the discharge head right there. When they discharge, we've got indicators on the outside of the airplane so crews can see in order to know if their bottles are, hopefully know if the bottles haven't, at least know they haven't been set off when they're doing a walk around. And so on the outside of the aircraft, it's just a little port with a plastic disc. And the red ones are thermal discharge. That means the bottle got too hot, the pressure got too high. These are particularly prone, again, in CO2 based systems because it's not as temperature stable. And then the yellow discharge is for an activation. The yellow discharge indicators if you have an actual activation of the fire bottle system. Hopefully, the crew would know if that's been activated. They wouldn't need to find one of these discs missing. Yeah. Correct. No. They're hooked to different, I don't know if this diagram shows it, it doesn't. The yellow basically is a little port off of, is connected like right off of here. So it just uses a little bit of the halon actually blows out through that and pops the disc out. Whereas this one is connected to the bottle. They don't show it here, but on like the other side of the bottle, there's going to be an overpressure relief valve, and that's what the red one would be connected to.